All right, welcome everyone. Now, if you, like me, are sick of staring at this scrolling rectangle, let's actually add a character texture and let's mess with that. So first, we need a character. If you already have your own, feel free to skip ahead. I'm just going to do some brief setup, just so we can all kind of have the same one. But feel free to use your own. It won't matter. So let's just come to itch.io. I did find one that I liked, so we'll come to Oakwoods, search for Oakwoods, and we'll grab this, and it is free, and it's this generic character asset, and it's this guy. Ooh, I like. So let us download it, and please feel free to donate, and then we will download it. As you can see, I've done this a few times, so it will open up this character and double click, come into the PNG and blue, and we want this character blue1.png. So we will come and just drag it to the desktop, because why not? All right, so we've got this character now, and I'm going to use a sprite just because it's great and it's pretty cheap, so I highly recommend it. But if you want to get your own, or want to use GIMP or something else that's free, please feel free. So I'm going to go File, Open, and we are going to come to our character blue. And as you can see, the issue we're going to have is that when we try and do our H frames and V frames, the character sprite sheet is a little off, so we will have to adjust it. As you can see, there's no pixels on the bottom, but there are pixel, like each square is 16, so that's 16 plus half of 16, which is 8. So we've got 16 plus 8, which is 24 pixels on the top. And we've got 24 pixels between each sprite sheet, but we have nothing on the bottom. So we do need to add half to the, so we have too many on the top and not enough on the bottom to make these all symmetric, because we basically need, each one needs to have 12 pixel space buffer, right? Half of this needs to be around this guy, and then the other half will be around each target. Otherwise, they're not going to line up correctly. So we need to subtract 12 pixels from the top and add 12 pixels to the bottom. And we can do that pretty easily in A-Sprite by coming to Sprite and Canvas Size. And with our height, we're going to want to, let's see, we want to add 12 pixels to the bottom. So let's do that first. So we're going to anchor at the top, and we're going to add 12 pixels. Where are you? And we're going to add 12 pixels. And as you can see, you can also just plug in those 12 pixels at the bottom if you prefer to do it that way. So now if we hit OK and we come and look at it, you see we've added 12 pixels to the bottom. And now we just have to do the opposite and subtract 12 pixels. Oh, no. OK, and now we have to add, subtract 12 pixels from the top. So sprite. Ooh, no, not sprite. Sprite canvas size. And now we're going to anchor to the bottom and subtract 12 pixels from the top. And as you can see, ooh, no, that's width. So let's not do that. And let us subtract 12 pixels from the height. And as you can see, we're subtracting 12 from the top, and we'll hit OK. And now we've moved it up. So now we have an equal amount of space each sprite has. So let's just come here and save it. And close a sprite. And now, oh, I still haven't set up hot zones. Arg. So we'll just drag in this sprite sheet that we've edited. And let's resize my window so it fits into OBS. All right, and now we've got our sprite sheet, and we need a sprite. So let's Control A, we'll add a sprite, and we'll drag in our character. As you can see, it's gigantic and it's also blurry. So there's two ways to fix it. If we just want to do it for this sprite, and since we're being lazy, we can just come in here to texture, and the filter we want to do nearest, and now it'll be nice and pixely. You can do it for all your whole setting if you're doing a pixel art project, of course, and come in here to texture. Let's see, where are you? Rendering. Where are you? Rendering and textures. And I believe you might have to have advanced settings on, maybe not. But under default texture filter, instead of linear, you can switch to nearest, and then all the textures you use will be the pixely form. All right, but we are just going to be lazy and do it that way. And now what we need to do is set up the animation so that we don't have this massive sprite sheet. And we've got, let's see, how many atriums 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 vertical and 1, 2, 3, 4, 5, 6, 7, 8 horizontal. So what did I say? 11 vertical and 8 horizontal. All right, and now we've got our character all set up, ready to go. So let's just move this sprite down, and remember, hold down Alt when you drag so you don't pull the world off. All right, but we'll keep that shader up there just so we can sort of see what we're doing a little bit. And now let us make a new shader for this guy. So let us come in here to Material, and Material, New Shader Material. You probably still have this now. We click on the shader, and we need a new shader, and we will call it Character Shader. And shader type is shader, mode is canvas item. We'll leave the default template so we don't have to do extra typing, and we'll hit Create, and we have our new shader. Oop. Character G shader. Where did you go? No. Okay, there it is. All right, so great. We've got this blank shader. Now we are going to actually take our color rectangle and apply the shader to it, so we kind of know what we're doing, and we can see sort of what we're applying to it. So instead of the color rectangle shader, we switch it to the character shader. And of course, it's not doing anything. So we're back to our sort of boring old blank rectangle. All right, so let's start seeing what we can do to this shader. Now, if you come here and we do our usual thing we did last time, so that was color equals, and let's see, we took the absolute value of the sine of the uv.x, and we multiplied that by 20, so we get so we sort of crunch it. We need to make a vector 4 of the absolute value of the sine, and we added time to it, and we multiplied it by 2 to sort of speed up the scrolling behavior. And then we need 0.0 and a 0.04. So this is going to be our red value. This will be our green. This will be our blue, and this will be our alpha. If we come here and hit save, what's wrong? All right. Oh, we have the absolute value of missing a. Okay. So now that we've got our parentheses right, but the problem is, as you can see, darn, we've just done this. We've just done this to our the whole thing. So we need some way of actually getting the sprite's underlying color, and we need to represent that. So we need some way of scanning over our texture. See if we comment that out. We need some way of actually getting the color information from our texture, and we can do that with the texture function. So if we look at the texture function, you'll see with our helpful autocorrect pop-up that it's going to return a vector 4, and that vector 4 will be the color. And we also have this thing called the sampler 2D sampler, and then the vector 2 coordinates of that. So we want to sample the texture and take out all the color information from this. And fortunately, Godot gives us an easy way of giving us what's quote-unquote a sampler, or really a thing that's going to look at all the different pixels along the way. So let us just set our color to equal the texture function that's going to return a color, and we're going to do texture, all caps, so it's another magic word that you're going to have to know. And this texture is basically the texture that's actually applied to the texture of the underlying object, so the sprite 2D. And as you can imagine, we'll give it the UVs. And all of a sudden, instead of getting a blank rectangle, you're like, oh, well, but that's just our character. But if you see here, this is really important, because what we're really doing is saying, this is the texture. Look at every single pixel along the texture and sample based on the UV coordinates. So it's basically the color of this pixel. Well, what is the color of the pixel at the UV coordinates 0, 0? Well, it's just empty pixel, right? It's with an alpha value of 0.0, right? It's a transparent pixel. So if we come here, ooh, my goodness. So if we come here, you can see this is just a blank pixel. But what if we do right in the middle, 0.5 and 0.5, right? That's the UV coordinates, UV x comma UV y is 0.5 and 0.5. Well, the texture is blue there. As you can see, it's his blue shirt. So we should have that nice shade of blue at that exact coordinate. And of course, if you pick this coordinate right here, you'll get the brown of his shield. And if you pick, down here, you'll get the gray of the boots. And then if you pick over here, you'll get the transparent pixel. So let's just see that. Instead of sampling just all the UVs, we can actually see what happens if we pick a vector 2 and just put in some points. So let's do 0, 0.0, 0.0. And if we hit 0, it's all translucent, right? Because the pixel up here that we've sampled on that texture of 0.0 is translucent. But what if we do 0.5 and 0.5? Oh, does this need to be actual pixel coordinates? Let us see. So this guy was, let's see, so we might actually need to put in full-on pixel coordinates here. So let's do, let's see, it was 12 down, so he is, let's come back to sprite. And we know he was 16, 16, so let's see, it's 16 pixels plus, so that was, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see, 13, 14, 15. So that's 16 plus 12 is 28. And then this is 16 plus another 12, 28. So let's try that. Let's try 28 by 28. No, still dark. All right, well, something's a little off. Why are you not turning all blue? Did I miss a little bit? Okay, I guess I was off a little bit. All right, I seem to be off a little bit in my calculations, but no matter. Oh, I know the issue. The issue is that our sprite sheet is actually gigantic. But if we just come back to our UVs, we should be okay. I don't know why that's not sampling quite right. Two coordinates. Yeah, I think that's texture coordinates for the entire texture, and our entire texture is actually a lot bigger. And the UVs that we're given are just for the size that is being seen. So if we had an actual sprite that was 16 by 16, so let's actually do that, and let's just convince ourselves that we're not crazy. Let's just make a new sprite that is, let's see, let's do 16 by 16 pixels, hit OK, and we'll just come in here and we will paint a sort of a blue target in the middle, and then maybe sort of this round target around, and then maybe like another blue. So, ooh, I don't know. So we'll just come in here and do this, and then we'll save. And let's save it as a PNG. And we'll call it little target. All right, and then we will come in here and we will add our little target, and we will add a sprite, and we will come in here with our little target, and let's see, we've got it right here, and we need to go to our texture filter nearest. Now we've got a nice pixely target, and let us apply our shader to this little target. So we need a material and the shader material, and we will plug in our character shader. All right, so we plugged in our character shader, and now when we come in here and we sample UV vector, so if we do their UVs, everything should look fine, and it does. But if we come in here and do vector 2 uv.x, vector 2 0.5 and 0.5, we should see that center blue color, and we do. So, I made stripes. So if we come in here, we've got that center blue color. If we move it off, let's say, you know, maybe that's what, 0.5. So if we do vector 2, 0.5, no, actually it'll be probably what, 0.6, comma 0.5 halfway down. Vector 2, and we save it. Now you can see we've hit that red color. So sorry, my apologies. And this is actually a good learning is if your sprite sheet is much bigger, those coordinates are actually going to be, the coordinates are actually going to be the UV, it's actually going to be the whole sprite sheet. But the UVs will just be the visible area. So I hope that kind of makes sense. So that is why we have to be careful. So obviously the UVs there are probably just between a tiny fraction of the whole thing. All right, so I hope that's kind of making sense. That if our entire sprite is that, then our vector 2s and UVs will line up perfectly. But if we have a much bigger character sheet, even though we've animated it down to the square, the UVs are representing just the on-screens part, but the coordinates are actually, the UVs are being translated to the coordinates. So that is helpful for us to know. All right, so sorry about that interlude, but we'll come in here and we'll do the UVs, and of course, we're going to be just fine here because the UVs are automatically translated to just the area, the visible area, and in this case they match up perfectly with the entire size of our little sprite here. Okay, so now what we want to do is we want to apply that sine wave we have to kind of make that neat little shader going over. So we've sampled our coordinates, and as you can see, you can definitely mess with the UVs. So if I multiply by 2.0, you can see we're starting to pull stuff out from under the sprite sheet, but of course in our little target we've now just moved it to the corner over there. But we're not going to mess with the UVs just now. We're just going to sample our texture. And the other thing we want to do is now we want to add a red sine wave to just the red channel, or we want to add a sine wave to just the red channel and add that to our pixel colors. So what we need is we need an intermediate variable. So let's do a float, and we'll do it red wave, and we will make it equal to that function we did. So remember, we want this will be the same as our gradient, right? We can, just like we did last time, we can call it gradient 2, and we can make it equal to the absolute value of the sine of, what did we do? We did uv.x times 20.0 plus time times, let's do 3.0, make it kind of wave a little bit faster. So we have now created that sine wave that we had before, that nice gradient sine wave that we had before. And we want to add that to our texture value. So we're going to need to break up our color. So let's do vector 4 temp color, and we're going to set that equal to our texture. So we're basically sampling. So now this temp color for each and every pixel is going to be based on where it is in the UV. But what we want to do is we want to add red. We want to add a red color just to the red portion of this vector 4. So if we want to set our final color, the color of each pixel, instead of the texture, we're going to set it equal to a vector 4. And we're going to break up our temp color. So our temp color dot red, and to our red we want to add our gradient, right? So so remember, we're already getting sort of an interesting effect here, because what's happening is that this is actually using the other constructor where we just put in a single value and it applies that the whole thing. But you can already see it's kind of doing this cool wave thing. But we want the blue and the green channels to be the same. So we'll do temp color dot green into our new vector, and then we want our temp color blue, and we want our temp color alpha to be the same as the prior. And all of a sudden we've got this neat little wave coming over here. Now, of course, if you just set your alpha to 1.0, you'll see sort of a weird effect. And I do want to show you this for a second. You can see like its boots are gigantic, and there's all of this other weird stuff happening. And part of that is because there is this issue with the import filter. So if we come to our character blue PNG and we come into the import section, and I've been showing you my desktop unnecessarily. Let's just come in here and stretch that back out. So I have been sort of unnecessarily, So anyways, where were we? So if we come in here, you'll see this process fix alpha border. And the problem with the fix alpha border is it's going to add sort of other additional information that we didn't necessarily want. So if we come in here to re-import, you can see we'll get rid of that weird halo that's happening, because essentially the alpha channel is there's a little bit of extra color information occurring as part of its way of fixing the alpha border. So just be aware of that. If it looks kind of funky, or you're dealing with some weird pixel things, you might have to uncheck that fix alpha border. But anyways, we just want the alpha from this guy. So we'll do temp color.a, and now we're keeping the original transparency information from the original pixel. So all we're doing is we're taking the red channel and we're going to add our gradient function to that. And by adding it to each pixel along the way from the UVX's, we are getting this nice little pattern. And of course you can make it, crunch it up a little further if you wanted to, so that you can really see that wave coming over it. But I don't know, I think I like the effect of actually a little bit less, so you can kind of see it just sort of moving from right over to the left. All right, so we're making some headway. We've gotten our texture information, and now we're broken up our texture colors, and then we've added a gradient to that in order to sort of add that highlight effect. And of course, if you just want to, if you got rid of the absolute value, now you're going to remember your sine function is now going to go negative, and you'll actually start pulling away red from that. So we can just see that really quickly. We'll just get rid of our sine. We'll get rid of the absolute value. And now, as you can see, we're pulling out red, so now we're left with more of a cyan color, which is probably not what we want. Remember, we don't want to be pulling away red from our texture information. We just want to add to it to make it more red and more glowy. So that's why we take the absolute value. I hope that makes sense. Because if we didn't do the absolute value, this gradient would actually turn negative, and we'd be subtracting that whole bottom part of the sine wave out from a red color and making it cyan. So there you go. So it'll get nice and bright and red, but then on the negative part, we're actually going to pull out all the red from our thing. All right, so saying the same thing over and over. And of course, let's just come back. If you wanted to make it a green wave, well, that's easy to do. Instead of adding to the red channel, let's just add to the green channel. Gradient plus our gradient. And now we've got this nice sort of almost poison-y effect. So if you get poison, you could have this like sort of glowing green thing. And if you were, I don't know, wanted to do the blue, come here and add gradient to that. And now we've got this sort of flashing blue thing. Maybe it's getting healed or something. If you wanted to do some really weird stuff, you could add to the alpha channel. But of course, you're going to see that background issue starting to come up if we start messing with the alpha channels. All right, great. Let's make it glow red again, just because that was nice. And of course, if you wanted to make it yellow, well, we could just add to both, gradient, and that'll be a sort of a yellow wave. Of course, that'll get really bright because now we're adding to two channels. If you did all three, you would see the white wave as we saw before. So now he's kind of flashing white, but he's kind of flashing in a neat way. Anyway, all right. You could of course make the wave go faster over him. So now he's really flashing. So that's, if you wanted a nice flashing white hit effect, you just add it all. And of course, you don't have to do all three. You can just add the gradient to, since we're going to add it linearly to everything. And sorry, let me slow it down so I don't give anyone a seizure. Let's go back to 3. 30 will be bad. So remember, the vector 4 can be composed of a vector 3 plus your alpha channel. And since we don't want to mess with the alpha channel, but we do want to mess with the colors, we can just come in here and do temp color dot RGB, and all of a sudden you're back to our usual one, and we can add the gradient a float value, which is a scalar. And of course, remember, you can add a scalar to that. Now, just so you know, you can actually do something called swizzling, which is really mess up the colors. So instead of, for example, if you wanted to have a filter that sort of changes color too, instead of doing the temp color.rgb, where we're just setting red channel to red channel, green channel to green channel, blue to blue, you can swizzle it. So instead of RGB, we can do RBG. And now we've swapped the blue and the green channels, and now its color is gonna be all messed up here. Let's get rid of the gradient just to show you the swizzling for a second. So now we've kind of changed it, and if we can do BGR, and now we've swapped now the red channel is getting the blue color, the green channel is getting the green channel, and the red color is getting the red. And of course we can swap those, BRG, and now we've got the red channel and the green and the blue. So you can really kind of mess with the colors a little bit. Let's do GBR, and you can kind of swizzle them around. All right, so that's swizzling. That's sort of remapping the vectors and changing the color. All right, so we've done that. We've got our nice, neat little glowing, I'm gonna stick it back to it. We've got our neat little glowing guy. Let's see, gradient, and then we'll do temp color G and temp color .B. And now we've got our guy back to our glowing red wave. All right, so the next thing kind of want to talk to you about, and actually if you look at our little guy, this is the same thing is happening to this color too. So we're sort of adding red to our UVs there too, so you can kind of see that happening. And why nothing is happening here? Well, we're already at blistering white, and so if you're just adding a red wave, you're not going to see anything. Now, if we get rid of the absolute value, we should see it start to move, because now remember, in the places we're pulling away red, we're going to see a darker than white. But since everything is bright white, you'll see that. Now, of course, if we come to our color and we go to, instead of bright white, we go to black. So let's just make these all black and hit OK. Why are you not changing? I don't know why that didn't change. Or maybe it's a modulate issue? Don't know. Anyway. All right. Let us go on to masking. So we need to make a mask. And let us come back to Sprite and we'll make our own mask. We'll just sort of see how this works. So let us make a new sprite, and we'll make it, I don't know, 32 by 32 pixels, or actually let's do 64 by 64 pixels, because I kind of want to show you resizing as well. All right, so we've got this nice little checkerboard, and we're going to make a checkerboard pattern. And we've got 4 squares, so let us just come in here, and we will make this black. And I'm going to hit G to do the paint bucket and do that. And then now let us select it. So come in here to, I think it's M for marquee. So we'll do M. We'll select our black square. We'll hit Control C and then Control V, and we'll drag it over here. And while it's still selected, let's change the color to white. So we'll just pick white from this palette, hit G, and since it's still selected, it's only going to fill in. That's a nice thing about Sprite. And now we've got 2. And we can come in here and we can hit marquee, and we'll just drag this here. Oh, drag too much. So here, let's do this. And we'll hit Control C and Control V, and we'll just move this over here. And we'll do Control C and Control V, and we will now offset it. And we'll Control V and do this, and Control V and move that here. And now we'll just duplicate this whole thing. Control C, Control V, and move it down. Now, the one thing with the checkerboard pattern you're going to want to make sure of is that the top one is the exact opposite and the right is the exact opposite of that. And the problem will occur when we start to stretch this texture out, as you'll see. All right, so let's hit save. And we'll call it checkerboard. And we'll do 64 by 64 .png. All right, so we've now saved this checkerboard, and now it's imported into our project. So we'll just do this and pull out our checkerboard. Okay, so we've now got this nice checkerboard texture. And let us mess with it a little bit. So we need a new sprite. Sprite 2D. And we're going to add our checkerboard to it. We've got a nice checkerboard, and okay, you know what? Let's just do this so that they're all nearest. And now we don't have to deal with that blurriness. All right. So we've got our neat little checkerboard texture. And now let's start messing with its UVs. So let's make a new, we can make a new shader to start with. And let's see. Come to our sprite, and we need a material and a new material. Getting sick of this one, and we come into our shader, and we'll go to new shader, and we'll call it checkerboard.gshader. All right, so we'll come into our checkerboard, and we have our blank shader. And let's now mess with those UV coordinates. So let's do, remember how we get our access to our texture? We'll say the color is going to equal, and if we just do vector for 1.0, 1.0, 1.0, 1.0, you'll recall, we'll make the whole thing white, but we actually want that texture information, so we need to get that texture information out. So instead of setting the color to a solid color, we want to get the underlying pattern. So we'll do texture function, which is going to sample across our texture, and the sampler we're going to give it is its original texture, and we'll do the UVs. And there we go. We've got our boring old checkerboard showing up again, as if nothing happened. But let us take a look here, and let's break up our vectors into uv.x and uv.y. So what happens if we start to mess with our UVs? Let's see what happens. So I'm going to take our uv.x and I'm going to do it by 2. And as you can see, something weird has happened. We have now sort of stretched our gradient out a little bit. And what's happening is right down this line here, if we see, we've sort of smushed our gradient, or crunched our gradient. Remember our little crunching thing, and that's not going to be 100%. That analogy of like crunching and shifting is not going to be perfect, but it'll work for the simple math, and so if that helps you. So what we've done is our UVYs are all the same. So we've basically sampled the texture across there, but look what's happened with our UVXs if we think about it. So at UVX of 0.0. So we'll just talk about our UVXs for now. Of 0.0, well, 0.0 times 2 is still 0, and so we've sampled our texture appropriately. But let's think about our UV .x of 0.5, and let's see what happened. So if we plug in our 0.5 into this, we've now multiplied it by 2, and what do we get out of that is 1.0. So basically what we said is at UVX, sample the pixel all the way over already to the right. So we've sort of reached the end of our grading because we've crunched it, and now we're just sort of pulling additional data from beyond our texture. So that's why you sort of see these stripes going all the way through here, as we've sort of reached the end of our gradient here because we've crunched it up. And for instance, you can do the same in y times 2.0. And if we look at that, we now have sort of smushed our gradient into this little box here. And you're sort of seeing it stretch from here, but actually if you draw an imaginary line here, by multiplying each by 2, we've actually created 4 quadrants, with this one, of course, being all black, that we've stretched out. So as you can see, we've crunched our gradient up, and we've made the texture sample smaller, but we've sort of run out of runway, if you will, because we're now pulling information from beyond where our gradient is. Now, if we come back to our character, because our actual texture is gigantic, right? The texture is all of those additional animations. When we start to crunch our shader here, so let's come back to our character shader. If instead of sampling from our UVs, if we multiply by say 4.0 and we crunch it together, you'll actually see all the rest of those sprites starting to get pulled in because it has that data from the texture. So we've actually like started to see all those other animations that are in there, and of course our sine wave is still going to travel over these as appropriately according to the UV that's visible, but we can actually see all that other stuff. But with our checkerboard, it ends, and so we're just going to start pulling in all this additional information. So that is not necessarily let's come back here. That is not necessarily what you want. Maybe you want this texture to repeat, and there's a way to do that. And we can come in here to our sprite that has the checkerboard. And if we come in here to texture, you'll notice, remember, this was how we kind of got rid of the pixely, the blurry effect. But of course now we've set that project wide. But there's also this repeat function. And look what happens when we say repeat. Instead of being inherit, which is disabled by default, if we click enabled, all of a sudden we'll get a repeating texture. And that's why it was important for these to alternate, because now if we repeat the texture and we had ended with black, white, let's say black, it'll now smush the two. It'll repeat the black up here, and you'll have this really like long black box when it repeats. But now we've repeated it, and no matter how much we crunch it, oops, sorry, we're in the checkerboard. There we are. No matter how much we crunch it, we'll keep getting more and more information. And of course, we can stretch the y, and we'll sort of smush it we'll crunch it in the y direction. If we do, like, for instance, 10, and if we do 10 here, now we have a much tighter looking texture. So that is how, or checkerboard pattern. So how can we use this information to sort of apply this to our character shader? So now that we know we can kind of crunch up our textures, or, you know, again, we don't even need this to be a vector 2. We can just say UV. If we're going to do it symmetrically, we can just do our UV, and that of course will be our default, but we can do that by 10.0, because remember, multiplying a scalar by a vector 2, you just apply that scalar to both the uv.x and uv.y component together. And why aren't you working? Oh, because and so we've done the same thing without necessarily breaking up that texture coordinates. All right, so now we're actually using those texture coordinates to do something. So let's apply this as a mask to our guy. Let's make it so maybe we see this a checkerboard pattern appear and scroll. And oh yeah, so I forgot to say, well, what can we do with this? Well, remember, now that we're sampling from our UVs, we actually know, and we've crunched it, well, we can actually scroll it too, right? So we can actually just add the time variable, and let's see what happens. And now, of course, we're adding time to both UVX and UVY, because again, we're adding a scalar, but as you can see, we started to scroll our textures because we're now sampling. And even though we don't have information here, because of this repeat that's enabled, we're now going to start to, anytime we run out of runway, when the time variable goes past where the texture is, it's just going to add more texture. So now we can have this sort of infinite scrolling. Let's say I want to scroll in the x direction. How can I do that? Well, I can just do plus uv.x plus time. Will that work? Oh, no, that's going to shift it up. So I think we do have to break it up. Sorry. So we can do UV, we can do vector 2, because we need a vector 2, and we'll do uv.x plus time. Oh, and we want to crunch it, so we'll do times 10.0 plus time, and then we'll just get our uv.y, and we'll also multiply that by 10, so we have that nice kind of crunched up gradient. And of course we need a closing parentheses, and so now we're scrolling in the x direction. And of course, if you wanted to do that in the y direction, simple, add time to our y variable, and now we're scrolling in the y direction. Of course, you can subtract time if you want to go down. So great. So now we kind of learned how to create textures that are infinitely scrollable. Now let's see if we can use this checkerboard pattern as a mask on top of our character and do some fun things like with that. All right, so I will just save you, and let's get rid of the time so we're not staring at something moving. All right, so let's come back to our character. And now I want to apply this texture to this guy and then do some fun things with it. So we need this texture information into our character shader, or sorry, into our character's shader. So how do we do that? Well, we need our uniform. So remember, a uniform was a way of getting outside variables into our shader, and it turns out that you can actually do a whole texture, and that is going to be uniform, and it'll be a sampler 2D. And remember, that sampler 2D was what we were stuffing into our texture. This magic texture is the sampler for the sprite itself, but we are going to actually plug in the this checkerboard pattern into our sampler. So we're going to have a sampler 2D, and we'll call it checker mask. Let's just do that, or checker text. And we will just declare it like that. And now you can see that a shader parameter popped up, and in it is the checker text variable. But as you can see, it's empty. So we can just come in here and plug in our checker text right into that. And now we have access to our checker text in our character shader. So here's our character shader. And we can convince ourselves by just saying, let's just come here and let's just set our color to equal vector 4, 1.0, 1.0, let's put 0.0, 1.0. So that should be red and green, so it should be yellow. And we've turned our character into just a yellow square, but of course that's lame, so we're not going to do that anymore. All right, so we definitely have access to that. Now let us sample from our mask or our checker texture. So initially we were setting our color to our actual sprite, but we can also set it equal to the checker text. And then of course we haven't set it to say color equals the temp color. And we are now sampling from our checker texture, but as you can see, it's just a black square, which is strange, and that's because we have a little bit of a mismatch between the sizes of things. And these UVs correspond to the UVs of our guy. I'm sorry, of our guy, and this guy has a different sort of texture coordinates than this one. So we kind of have to play around with the checker texture and see. So let's just set the color directly equal. Let's get rid of this temp. And let's see if I start to mess with our checker texture. You can start to see, oh, a little bit of white starting to peek out. So let's do 10. And as you can see, ooh, okay. And as you can see, we're starting to get into this territory where we're seeing our thing. And as you can see, it's a little bit stretched out because remember our character sprite sheet was not actually a perfect square. Remember, it's a little bit of boxiness. So our UV coordinates, which are based on this sprite sheet, which is, a small section of this, is actually going to be is going to cause our mask to be a little bit stretched out. But that's okay. We would have to adjust for the aspect ratios. So we would have to do, for instance, it's like 11 by 8, so we would have to 11 by 8 squares. So we would have to multiply the x by a little less than the y, so we would crunch the y just a little bit more, so we'd perfectly obtain a square. Now, the other thing we realize is that even though we had applied our our nearest filter to our original texture coordinate, this one is still blurry. And not only is it blurry, but it's also not repeating. And if I come in here to our character sprite, which is which guy? This guy. All right, our original sprite. I should name these. This is our character sprite. If we come in here and we repeat enabled, it doesn't actually affect this sampler that we've stuffed in. It just affects the original sprite. So let's just for a second. Show you that. So how do we do that? Let's just comment these out. So I'm just going to Control K to comment these, and of course it's going to use // for the comments. If we set our color to equal the texture, and in this case we're sampling from our base texture and our UVs, now we've set repeat enabled. So if I multiply our UVs times, let's say 30, now you can actually see what it is repeating is it's repeating the underlying texture, but it's not really repeating our sampler. So we do need to adjust that. All right. So let's come back here and we'll just Control Z our way back to success. Okay. So let's make it 20 so we can really see what's happening. All right. Let's start to make it even smaller, like 40. 50? Actually, let's break it up. I lied. UV, so we'll make a vector 2, and we'll make our UV dot x times 50, and we'll actually crunch our uv.y just a little bit more. So let's say just to make it, let's make it by 60 and let's make sure and we also have to close that. And now it looks a little bit more square, maybe still a tiny bit stretch, maybe if we do 65. All right, yeah, so now it's a nice square. But it's still blurry. You can still see that blur. So we need to fix that. And this is where we can add those sort of magic things. And if we add a colon after our checker texture and we say filter, you can see we have these options, filter linear, but we want to filter nearest. And now, when we hit save, all of a sudden we've gotten rid of that blur. So we're basically saying, just like you did over here to our original texture, I want you to do the same filter for this, and we'll filter nearest. And of course, if you filter instead linear, you'll go back to that sort of blurry filter. But we want nearest. Now the other thing we want to do is we want to repeat this texture. We don't want to just stretch out this gradient and just take data from whatever the last pixel was and then stretch it out. So right, last pixel here would be this little black pixel, so it's going to stretch that one out and just go fill that entire area. So the other thing we want to do is just hit another comma, and we want to repeat it. And instead of repeat disabled, which it is by default, we're going to enable the repeat. And now when we do it, all of a sudden we have this nice, our nice checkerboard texture is back. But of course we're setting the color to this gradient, or sorry, we're setting our color just to our mask, and that's not what we want. We want to see our character. So let us keep this information, and let's put this into a mask. So we'll do vector for mask, or checker mask, and we will set that equal to this guy. So we'll sample, this mask will sample the checkerboard texture. And because the repeat, enable, and filter, it's going to get all that information. But we just want our happy little character. Let's see, character texture, equal texture, and we're going to set it to our texture and our UVs. And then we'll leave the gradient alone for a second, and we'll set our color equal to our character text, or text. Let's do text. Why are you complaining? Oh, because there's no semicolon here. Ha, got me. All right, and now we've got our character back. But let's sort of mess with this character a little bit by dealing with this mask. So how do we do that? Let us decide. Let's say we want to, wherever the texture is black, we want our alpha to be 0. And wherever the texture is white, we want the alpha to be opaque. So we'll sort of like, anywhere the alpha is, anywhere it's black, we'll make it transparent, and anywhere it's white, we'll make it fully opaque. And that is the nice part about using white and black for masks, is that you're going to be multiplying by 1 or 0, and so it's almost like a bit. You can flip it on and flip it off like a true false. So let us come here, and we will just take one value. So let us do float checker sort of multiply. Or actually, here, instead of doing that, let's do checker text. So that's our. Oh no, we're gonna have a problem with that. Checker text color or sample. Now let us actually instead. So now we've sampled over that and we've added all these things. Let's actually take one of the values from that. So we're just going to take a float, and we'll call this our mask, and we'll set that equal to the checker text sample. And we'll set it just equal to its red channel. And now if you think about it, the red channel is, since these are white and black, the red is going to be either 1 or it's going to be 0 when it's black. And now let's break up our color. So it's not just the text, the character texture, but it's going to be all the little parts of it. So checker text dot red, And since I'm only going to mess with the alpha channel, I'm going to do RGB for red, green, blue. And remember, that's going to return a vector 4. And if I do character text dot alpha separately, it should be exactly the same. We haven't really changed anything. We're just splitting it up. But now I want to mess with the alpha. I'm going to mess with it by multiplying it by the checker text sample dot r value. And we stuff that into a variable called checker mask. So we'll do checker mask. And now if we do it, oh my goodness, look at this. We have done something really wild to our character. We have basically taken the data from this mask, and just like we've sampled the UVs, because remember, we were able to sort of show what the mask looked like, and we have applied that mask by multiplying, just taking the red value and multiplying that red value, whether it's 1.0 or whatever. And now if you did alpha here, this would be wrong, and what's going to happen? It's just going to be solid again, because remember, our mask is entirely opaque. Whether it's white or black, the alpha value is 1. So if we strip out the alpha value from our checker mask, every pixel, everywhere we go, everywhere we sample is going to be 1.0. And so we're just multiplying our alpha values on our character by 1.0. And of course, if you just do 1.0, wherever the character is opaque, this will be 1.0 times 1.0, and wherever it's translucent, 0.0, or you're just multiplying 0.0 by 1.0. But if we take the actual color information, the red, green, and blue, now I can, as you can see, I can do blue here, and that'll be the same. I can do green here, and that'll be the same, because these are either white or black pixels. So I hope that makes sense. But as you can imagine, we can start doing wild things with this, because we also know that we can change the way we're sampling our checker texture. We can sample it like we did over time. And I think we had our gradient here, which was this sine wave, would be really crazy. But let's just start with our time. So now I want to sample this over time, and we've broken it up. So let's scroll this pattern over our character, and you can see now our mask is moving. We're not changing the way we're sampling our character, but we're changing the way we're sampling our mask. And as you can see, this transparency is going to sort of wash over it. Just to show you that we can do other things with this mask, let's say we want a red pattern to go over this. Well, for now we were multiplying this by, we were sort of messing with our A value, but let's just break up our character texture back into its individual components. So we have red, character texture dot green, character texture dot blue. So this is just, we're basically just saying, take our normal sample, and of course we've got the same, but here let's apply our mask to the red channel. So let's add our mask, check our mask, to our red value, and let's see what happens. So as you can see, our mask is moving with time. Now let's just get rid of time for a second so we can see what's happening. You can see we've now just basically added wherever our mask to the red channel, and so all the black spots are going to be the underlying color, because we're not adding anything to our red value where the value is 0, but wherever the value is red, we are adding that to the pixel color. So here we're adding basically 1.0 to the red channel, so it's going to be bright red, and then of course you still have underlying green and blue coming through. So I hope that's making sense. And of course the alpha is just going to be the original character's alpha, so we're not changing that in any way. Of course, if you added the mask to that, then you would start to see the underlying values. All right. So I hope that's starting to make sense, that you can sort of use the masks to do some interesting kind of fun stuff. And hopefully in the next one, what we'll do is we'll put this all together and make that flame I showed you. But I think this one has kind of gone on long enough, so we've looked at sort of how to import masks, how to add these sort of magic numbers, add these hints in order to get better behavior out of the textures that we're importing or the masks we're importing. And you've learned how to sample the underlying texture using this, and you've also learned how to sample an imported variable as well. All right, so good luck in your shader quests, and hopefully we will continue this on as we go. All right.